In this video, we'll be looking at elastic force. Elastic force is the force a spring exerts on an object. As shown in the diagram below, let's stretch the spring by fixing its left end to a wall, assuming the mass of the spring is negligible, and pulling on its right end with a force of magnitude F. Let's consider the force acting on the spring, equals gravity plus contact force. First, since the mass is negligible, the gravitational force acting on the spring is zero. Next, regarding the contact forces, the spring is in contact with both the hand and the wall. Therefore, the spring is not only being pulled by the force F exerted by the hand, but is also being pulled by the wall. Since the spring is at rest, the force exerted by the hand must be equal in magnitude to F, based on the principle of equilibrium. In other words, applying a force of magnitude F to the spring is equivalent to pulling each end of the spring with a force of F. On the other hand, the hand experiences a reaction force F, the force with which the hand pulls on the spring, from the spring, right. The force that a spring exerts on an object is called an elastic force. The direction of the elastic force, whether the spring is stretched or compressed, is always toward its natural length. The magnitude of the elastic force is proportional to the extension or compression, x, m, from the spring's natural length. This law is called Hooke's law, named after its discoverer. Elastic force. F equals kx, spring extension or compression. The proportional constant k, n per meter, that appears in the above equation is called the spring constant. As shown in the figure, one end of a spring of negligible mass is fixed to the upper end A, which is tilted by an angle theta, and a small object of mass m is attached to the other end of the spring. The small object remains at rest because the forces due to gravity and the spring, as well as the static friction force, are in equilibrium. Let k be the spring constant, mu be the coefficient of static friction between the small object and the plate, and g be the acceleration due to gravity. 1. When mu equals 0, find the extension x0 of the spring. Since the coefficient of static friction mu equals 0, the frictional force is 0. There are three forces acting on the object: the force due to gravity, mg, the normal force, n, and the elastic force, kx0. Let's find the extension x0 of the spring by balancing the forces in the direction of the slope. Kx0 equals mg sine theta. x0 equals mg sine theta divided k.